Good evening, everyone. How are you all? I hope everyone is well in this COVID situation because we have to be very safe. My name is Kishore Jhagroo. I'm a senior lecturer and coordinator of the Engineering Asset Management MSc program with the Department of Mechanical and Manufacturing Engineering, Faculty of Engineering, UWI and Augusta. My presentation is really a guide in the use of the existing maintenance and reliability theories to enhance equipment reliability and availability in Caribbean industries. And the question is, why is there a need for this guide? And what I've found is that 80% of my EAM students who are doing the capstone final year projects, I'll always ask the question, why is it that my industry is not doing what they are supposed to do, although they know what what has to be done? And most of the projects that they do deal with improving the maintenance and reliability strategies, mainly in the area of implementation in a lot of their industries. The models, which are based on maintenance and reliability theories, which are actually put together to form a synergistic relationship, these models will be the total improvement model, the change management model, the reliability improvement model, the modified PF curve, the CMMS repair strategy, and the strategy improvement model. And all of these will be used and discussed with respect to continuous improvement and with respect to management accounting to make sure that this continuous improvement is in fact motivated by management. And this model, the total improvement model, talks about the industry at different stages of its development. The vertical axis, the y-axis will be effort, the x-axis will be time. And that first stage is a stage which we refer to as being unconsciously incompetent. We will define it a little later on. But unconsciously incompetent when a lot of companies are not functioning in a benchmarking mode where they are benchmarked, but they are really operating internally. Everything is internal. When they have benchmarked themselves at this point, they now become consciously incompetent and they now realize what they have to do. And like I say, we'll define that further. And then you have this first hump which appears, which they have to cross to get to become consciously competent. And then when this system becomes embedded, they now become unconsciously competent. However, this is only the first hump. And this is really getting people to do what they are supposed to do in preparation for the next hump, which is the first of the technical humps, and many more coming after that. So that in this first stage of being unconsciously incompetent, this was terms that were developed by N. Birch, and I've used the Wilson in his book, talking about the level of confusion in the different maturity stages of organization. Now, at this unconsciously incompetent stage, which is here, you have ad hoc planning and scheduling is in place. Little knowledge of root cause analysis. RCM considered very expensive. Maintenance is carried out in a reactive mode and in firefighting mode. Then when they have benchmarked themselves, according to Wilson, you are into the area of awareness, where basic knowledge of our root cause analysis and troubleshooting exists. RCM training is completed. Condition-based maintenance started with vibration analysis, and there's an understanding of TPM, and this is established by top management. Then you reach having crossed and introduced the effort that is necessary to cross this first hump. You have now started to do what you are supposed to do. You have now entered the area of being consciously competent, where planning and scheduling is performed for all future work. Root cause analysis training programs are in place with committed leaders. There's a full pilot RCM, FMECA, failure mode, effect and criticality analysis is carried out. Management support, condition-based maintenance and internal training is promoted. TPM training is in place and a 12-month plan established. Now, it is only when these systems are fully embedded and they now become part of the way work is done, you become unconsciously competent, where an integral and flexible planning and scheduling system exists. Root cause analysis is demanded by leaders similar to RCM, TBM, and TPM. And what do we need to make this change? And here, in this first stage of being unconsciously incompetent, and even consciously incompetent, the turmoil in the organization is very high. And the aim of the change agents or the reliability agents, or the AM students, will be to control this turmoil. Cannot get rid of it, control the turmoil, but keep it in a particular direction in which you want to go. Now, there's no silver bullet to take you through this first hump. You must cross this hump in order to make the systems function. Here we have the modified PF curve, which talks about the understanding of equipment performance. All equipment operate when installed new at the upper limit of functionality, and then a lower limit of functionality, depending on the industry, is determined to say when the equipment reaches that point, it has failed. Now, every piece of equipment that has any type of dynamic motion, including batteries that have movement of electrons, there is a certain design level of deterioration. However, that is a design rate. When, however, that deterioration increases and the rate of deterioration has increased, you have reached the point P, which is your precursor to your failures. And you know within a certain time period, the PF interval, failure will occur. And taking that into consideration, one needs to know when in this model, the reliability improvement model, when equipment is in operation, you need to do, according to the PF curve, your CM, your condition monitoring, your preventive maintenance, to get it to run as long as it could until that point P, when you have an alarm which says, okay, something is going to happen. Then when you know that the equipment is about to fail, you do not allow it to fail in terms of a catastrophic damage. You know that the bearings have gone and you want to change the bearings before the shaft has deteriorated. You then do your failure analysis and you develop the root causes of your problems. And then you develop your QA/QC document, the quality assurance, quality control system for your repairs. And some of this will even go back into your operation and into your failure analysis. One has to note that everything here will be planned and scheduled so that everyone is in control of the information, and all of the information is stored in your CMMS system, which could either be an electronic system, a CMMS, or it could be a manual data collection system. And this here is a case study showing, if you need to look at the report or the paper to look at these fine writing, but just look at when the equipment has a problem in the field information is then put into the CMMS. When it is sent for repairs, that information is then pulled from the CMMS and it is then repaired. When the repair is completed, the information put back into the CMMS, and then the equipment is sent outside into the field. Then the equipment is placed in service, the information placed into the CMMS, and then you determine, is it good for service or does it need to be repaired again? If it is good, you then go ahead, go into continuous improvement, do your KPI reports, etc. If it has to be returned, it then has to go through the cycle again. In order to look at these systems and to make sure that you are in the right direction, you need to have your KPIs. And this KPI tree is determined and is identified by these three: maintenance cost, mechanical availability, and cost of business cost in the lagging KPIs. And then you have the leading KPIs below, which will tell you if you are having problems with these at the top. So these are really the KPI that you will follow to look at your trends. And in order to convert the plans into actions, you need to have your strategic plan, which will be converted through the different levels of the organization to your execution. And my point to my students is that if, when you execute, it doesn't add value to the plan, to the strategic plan, then you are not spending good time. Conclusion: there are no silver bullets. You must take the effort. You need to sweat the system. You need to use the RCM, TPM, Kepner-Trego, Reddin's 3D leadership, Six Sigma Black Belt systems. Strategic plans need to be seamless, and it has to be driven by management. Characteristic changes are motivated by management, reviewed and audited by reliability engineers, spearheaded by frontline employees. KPIs and management accounting is necessary for involvement by management. There's a method of continuous improvement, and synergistic work relationship by all stakeholders are necessary. And I will go back to the first two. There is no silver bullet to get you through any of the humps, and you need to sweat the system to go over the hump. We have our references here: Abineti Babati Jardine, who is one of our external lecturers, Mowbray, Doc Palmer, he's also one of our Zoom presenters in our short courses, Suzuki and TPM, and Wilson. Questions? Thank you very much. Any questions?
Thank you for your presentation. Dr. Mujafar, do we have any questions? So we don't have questions, but maybe one brief. How do you estimate perspectives to apply the technique you developed locally, or do you know or mention about very positive examples in other countries? Very briefly, we don't have much time.
Was that the question, Doctor, Professor?
Yeah, it's my name, Professor Eskin.
Yes, Professor. Could you repeat? I didn't get it clearly.
Eskin.
Yes, Professor Eskin. Yes. Any? Could you please repeat your question? I didn't
The question is that how do you estimate perspectives to use the technique you suggested in local industry, and also just briefly mention, are there any examples of successful using this type of approach in other countries?
No, well, what I have done some presentations externally. For example, I did one at Seneca College in Toronto, and however, I have not collected any data indicating if there were any successes. However, from discussions with the some of the lecturers at the University of Toronto, they have looked at it and have, it is in line with some of the discussions that they have been having with the industries, especially with Professor Jardine and his group.
Okay, thank you. So we should, thank you very much. We should proceed. So thank you very much for your interesting presentation.